Hello friends, today's question. In the figure, both pulleys and a string are massless and all surfaces are frictionless. Given M1 1 kg, M2 2 and M3 3 kg, find the tension in string and acceleration of M1 and M3. So we have, you can say, three masses M1, M2, M3, and we are supposed to find out their individual accelerations. So first of all, let us assume that M1 moves towards right side by distance of x1 and M2 by x2 and M3 by x3. So we can write this, the constraint relationship between M1, M2 and M3. You can say M1 moves rightward by x1, M2 moves downward by x2, and M3 also moves downward by x3. x3. So therefore we can say that x1 will be equal to x2 plus x3, and from here we can say that a1 is equal to a2 plus a3 by taking double derivative of this equation. Let us call this equation number 1. So let's draw the free body diagram for our M1, then M2 and then M3. So we can write for mass M1 here it is tension T, and this is M1. In the downward direction we are going to have M1G, and there will be a normal, let us suppose that is N1, moving towards the right side, acceleration A1, and because of this M2 block, let us suppose there is a normal N2, sorry, let it be N. So we are only interested in horizontal part. So from here we can write the equation for the motion as T minus N is equal to M1A1. Okay. So let us this be equation number 2. So for block M2, for mass M2, this is M2, it is going to have M2G, tension T, downward direction it is moving with the acceleration of A2, and there is a normal because of M1 and M2 in this direction N, and it is going to have also a vertical horizontal acceleration, and that will be our A1. Okay. Therefore we can write the equation as N is equal to M2 multiplied by A1, N is equal to M2 A1, and for vertical we can write that M2G minus T will be equal to M2A2. Okay. Let's be equation number 3, and this be equation number 4. And finally for mass M3, for mass M3, downward it will be M3G, tension T, moving the acceleration of A3. So we can write the equation as m3g minus t will be equal to m3a3. That will be equation number 5. Now we are going to use 1, 2, 3, 4, 5 all the equations and try to solve it. Let me write all the equations here. So we have a1 is equal to a2 plus a3, equation number 1. We have t minus n is equal to m1a, equation 2. We have n is equal to m2a1, equation number 3. And finally m3g minus t is equal to, I think I missed one equation, let me write, yeah, m2g minus t is equal to m2a2, equation number 4. And finally we have m3g minus t is equal to m3a3, equation number 5. So we have these 5 equations and we are going to solve it one by one. So let us use equation 2 and 3. Using equation 2 and 4, sorry, not 2 and 3. Okay. So we get this as t minus n is equal to m1a, and we have m2g minus t is equal to m2, this is t m1a1, and this is m2a2. Okay, and if you add them, t cancel out with t. This is using equation 2 and 4, equation 2 and 4. So we get this as m2g minus n is equal to m1a1 plus m2a2. We substitute the values, yeah, and n is our m2a1. We substitute here, we get m2g minus, you can say, using equation 3, we get m2g minus m2a1 is equal to m1a1 plus m2a2. Substitute the value, m2 is given as 2 kg, so this will be 20 minus 2a1 is equal to m1 is given as 1 kg, so this will be a1 plus this will be our 2a2, and this will be giving us, this will be 3 and 2, so we get 20 is equal to 3a1 plus 2a2, question number 6. And we use equation 2 and 3. From equation 2 and 3, 2 is our t minus n, m1a1, and 3 is n is equal to m2a1. We substitute it here, we get t minus m2a1 is equal to m1a1. So from here we can say t is equal to a1, we can take as common, so this will be m1 plus m2, and m1 is 1 kg and m2 is 2 kg, so we get t is equal to 3a1. Let us suppose this is equation number 7. Now we use equations 2 and 5, or yeah, we can subtract them. Let us use 4 and 5. So we can say our m2g minus t is equal to m2 a2, and we have m3 g minus t is equal to m3 a3, and this is using equation 4 and 5. Using equation 4 and 5, and we subtract them. This will be plus and this will be minus. T goes with t, and we can say from here g is common, so this will be m2 minus m3 is equal to m2 a2 minus m3 a3. Substitute the values. We get g m2 is our 2 minus 3, and this is 2a2 minus m3 is 3a3. So this will be our minus g is equal to 2a2 minus 3a3. Our g is 10, so we can write this as 3a3 minus 2a2 is equal to 10. Let this be equation number 8. So now we are going to use all these equations, okay, and we are going to try to solve them. It is given that equation number 8 is 3a3 minus 2a2 and 10. So using equation 6, 7 and 8. 6, 7 and 8. Let me write them here. 7 was 20 equal to 3a1 plus 2a2, and t is equal to 3a1, and lastly we have 3a3 minus 2a2 is equal to 10, and we already have a1 is equal to a2 plus a3. Let me 1, 6, 7 and 8. So we have 3a3 minus 2a2 is equal to 10, and we write that we can use this equation. So this is equal to 20 is 3a1, and a1 is a2 plus a3, and this is plus 2a2. Okay. So we get this as 3a3 minus 2a2 is equal to 10, and this comes as 3a2, and this will be your, one second, this is 2a2, sorry. So this comes as 5a2, and this will be 3a3, and we subtract them. This is equal to 20. Subtract them, a3 goes with a3, and we get this as minus, so this will be a minus 7. a2 is equal to minus of 10, minus goes with minus, and from here we can say that our a2 is equal to 10 by 7. So this is the acceleration of a2 was for m2. So this is acceleration of m2. Next we are supposed to find out the acceleration of m3 also. One second. Yeah, So this will be acceleration of m2 downward. Okay. Yeah. So net acceleration of m2 will be a little bit different. But this acceleration of m2 will be in downward direction. Okay, because m2 is having two accelerations. One is downward a2 and another one is horizontal, that is a1. So net will be somewhere here resultant, which we are going to calculate later on. So next we are going to use another equation to find out our a3, and we already know that equation is 3a3 minus 2a2 is equal to 10. We substitute a2, we get this as 3a3 minus 2, 10 by 7 is equal to 10. So we get this as 3a3 minus 20 upon 7 is equal to 10, and we get 3a3 is equal to, this will be 90 upon 7. So we get a3 as 30 upon 7 meter per second square. And from here we can find out our a1 from equation 1. a1 is equal to a2 plus a3. a2 is 10 by 7. This is 30 upon 7. So this will be coming as 40 upon 7 meter per second square. So now we are going to calculate the net acceleration of m2. You can see net acceleration of m2. So this is m2. Downward direction is a2. In horizontal direction is a1. So net acceleration, let us suppose, is capital A. So from A we can say that A is equal to a1 square plus a2 square and its square root. We already know values. a1 is our 40 by 70, 40 by 7 square, plus a2 is 10 by 7 and its square root. So we can say that our a, this will be 1600 and this will be 1, that is 1700, 7 and its square root. So this will be coming approximately as 41, or we can say 5.8 meter per second square. And we are also supposed to find out tension in the string. Okay, so we can say that tension in the string, that is T, string T, we already know the formula is 3A, 3A1 rather, and A1 is our 40 by 7, so we get tension T is equal to 3 multiplied by 40 by 7. So we can say that our tension T is equal to 120 by 7 newtons. Okay. This is the tension in string. The tension in the string. Okay. Yeah, so this completes the question. Thank you.